we're going to talk about the relationship between the unit circle and the sine graph. I think I actually liked this one better, or maybe not. Let's see. So the sine graph is, it's going so fast. Okay, let me go back here for a second. The sine graph is actually the relationship between which variable, x or y, guys? Sine is y, right? We did cosine sine. So sine is the y variable. When we start talking about the unit circle, okay, the y variable starting right here at 0, well, what's the y variable here? Went over 1 and up 0, right? I'm struggling. Okay, so we went up 0, so this starts at the origin. As we go around the circle, if I go to here, the y variable is this little tiny distance here, right? So as we went around a little way, we had this little tiny distance here. As we go further around, the y variable is doing what? Increasing, okay? And it gets longer and longer and longer and longer until it hits what? Okay, at 90 or at pi over 2, it's as tall as 1, right? If I copied all those little sticks and I brought them over here, they're getting longer and longer until it gets to 1, okay? Then what happens to the y as we go into this quadrant? It decreases, but it's still positive, yes? Okay, so the y value is getting smaller and smaller, but it's still positive, okay? I didn't draw it well there. And then we get to what's the y variable here? The y variable is 0 at pi, right? It's down to 0. Okay. Then what happens to the y variable when we get down here? It's getting longer and longer, but it's what? Negative. So it starts out short and it gets longer and longer, but it's negative until we get to here, which in radians is 3 pi over 2. And then here it's negative, but it's starting to get smaller and smaller. Okay, I did a really crappy job of drawing that. But the idea is that the y is increasing, then it's decreasing, then it's negative, but it's getting more negative, and then it's going back towards 0. Okay? So on the unit circle, if I show you this again, we are looking at tracing the y, which on this picture is the red. You see the red? Okay, and that's why it's red over here. It's just going so very, very fast. I think I have one that I can manipulate a little better, but this one has all 3 of them on at once. So the y variable on this one is what color? Can you tell? It's the green. So as it goes around, it makes this pattern over here, starting at the origin. Okay, so this one is in degrees. We can change it to radians. All right. What else did I play around with? I don't remember. We could get rid of the circle and just look at the triangle as it goes around. All right. So have you all done this at some point? But you need to remember that the sine is the one that starts at the origin. Okay. And it takes an entire 2 pi to finish one cycle. Now, do you remember even and odd functions? By the way, this repeats forever and ever, okay? It is periodic, meaning it will continue to do this shape. So, is this an even or odd function, meaning what symmetry does it have? It has origin symmetry, so it is an odd function. All right, if we talk real quick about cosine, is cosine the x coordinate or the y coordinate? Guys, please put your phones away. The x coordinate here is all the way over to here. You went 1 unit. So at 0, x is 1 unit. Now, as I go up to here, how far over am I going? Like that, right? It's getting shorter. And as I go up here, it's getting shorter and shorter until it gets up here, the ordered pair is 0, 1. So it starts at 1 unit of x over, and then it keeps getting smaller and smaller and smaller until it goes down to nothing. And that's at 90 or pi over 2. Okay. So should be doing this, guys. My sticks aren't very good here. And then as we go this way, though, the x is doing what? If I'm over here, I went over just a little bit, right? Then the x is getting longer and longer. The x is the amount of over, but it's negative. So it's short, but it's getting longer, and it's negative. So the x is doing this until we get all the way over here to -1. At pi. And then it's still negative, but what's happening down here somewhere, the amount I went over got smaller, right? So it's getting shorter again until it gets back to 3 pi over 2, because down here this is 0, -1. So the x is down to 0. And then the the x, here, the x I had to go over just a little bit, and then I went over further and over further and over further until I went all the way over 1. And that's the cycle by 2 pi. So that's why this one starts at the maximum when we start at 0, and it repeats the same shape as the other one, but this time the symmetry is what, guys? This time if we were to continue the pattern on both sides, it would be y-axis symmetry. It's even because it has y-axis symmetry. And my drawing is so bad. I don't know if that's any better, but it's supposed to look like you could fold it in half here. We good? All right, and I could show you on the y-axis or the x-axis here, it starts at 1, so it's the blue on the picture. Okay, and on this one, it's, what is it, the purple? Yes, it's the purple. It's how far over it's going. So it looks like this. Okay. Now, tangent is the one students struggle the most with, and tangent's not actually on your homework, but I do want to do the introduction to tangent today. Tangent is actually the slope. This is a huge concept in trigonometry, that tangent is slope, because the definition of tangent is we put, I'm sorry, not what I meant to write. We put y over x when we were doing the tangent, or sine over cosine. Does that sound familiar? Okay, so what else is y over x, guys? Remember, change in y over change in x is slope. So this is a little bit trickier for you to think about. But what is the slope right here? Yeah, it's 0. There is no slope. So we start at 0. Okay? This slope might be like up 1 and over 10. It's a really tiny slope, right? So that's tiny amount here. As I go up, okay, it's a little steeper. Now, what happens when I hit somewhere in here? At 45, I went over the same amount as I went up, right? That's what a 45, 45, 90 is. So it's going to hit 1. But does it stop? No, the slope increases. This one might be over 5 and up 7. This one might be over 2 and up 10, right? This one might be over 1 and up 75. I don't know. It can get infinitely large. The slope doesn't stop increasing. So the slope gets longer and longer and longer until we get here. And then what is this slope? What is the slope of a vertical line? What's happening? Undefined, right? The slope of a vertical line. That's why there's an undefined place, okay, in the tangent graph. What happens when we get over here to the slope? What's the slope of that line? What? It's negative. It's very steep, but it's negative. So it's very far down here, but it's negative. And then the slope gets flatter and flatter until it gets back to 0. All right, I don't have this drawn well, but this is the shape. It's increasing, and then it's down here decreasing. I mean, it's getting closer to 0. Now, that's not the way we usually draw a tangent, but where would the symmetry be if we drew this? We continued this. Anybody see where the symmetry would be? It's origin symmetry, right? So it's odd. Now let me talk about why we're done when we hit pi. Look here, guys. If I get to here and then I start on this line, is that not the same line that I had over here? Has the same exact slope as it did in the first quadrant. It's just a continuation of the line. So we've hit all the possible values by the time we get to pi. So this is pi, the undefined place is pi over 2, and this is an entire period of pi. All right, we'll do tangent some more next week. Everybody got something down there? All right, so now we're going to talk about worksheet 10. Yeah, I said a couple times there was more unit circle practice on 9B if you wanted to practice it. So that's what it was for. If you need to do a retake, you can go back and practice it there. But so today we're just doing sine and cosine. And all we're going to do is amplitude and period changes. No shifting up, down, left, or right, okay? So you do have to know all of these ideas. The domain is all real numbers because it continues and repeats left and right. Now we do a lot of sketching from like 0 to 2 pi, but that doesn't mean it stops there. Everybody good? I'm just not going to make you sketch 75 periods of it, okay? The range for a normal sine graph is -1 to 1, and those are the same for sine and cosine. The y-intercept, though, for sine is 0, and for cosine, it starts at its maximum, so the y-intercept is up at 1. All right, and then this one repeats, they both have a period, or they repeat every 2 pi, so it means it intersects every pi here. This one, though, doesn't intersect until pi over 2, so that's when it starts to repeat. And I will not ask you to write it like that. Okay? It is continuous. This you do need to know. Okay? Sine is an odd function, and cosine is an even function. And I'm not going to ask you about this. Where are the extrema? All right. They do not have an end behavior. Okay, because it oscillates. All right, this is the way the book writes this, and you may have learned it this way in Trig, but when you go to do the shift here, it gets messy. It's C over B. Did you learn it C over B in Trig? Does anybody remember the phase shift? Okay. We're going to factor that out so that you just have to learn the phase shift is C. Okay. The phase shift is C instead of C over B. That's written wrong there. But we're not doing that today. This one we're doing today, we're going to talk about amplitude. The amplitude is half the distance between the max and the min. Okay. So the amplitude is where is that midline and how far above and below does it go? And it comes from the number in front, but the amplitude is defined as the absolute value. Okay, because it's a distance, it's positive. So you can't ever tell me that it's negative. We will talk about what a negative does today. What would a negative do out in front of anything? Reflected over the x-axis, yes. All right, then we're going to talk about period. When we drew these, we realized that they repeated every time we went around the unit circle, which was 2 pi. So the period is just 2 pi. But there's what's called an inverse relationship with that b out here. Remember how we said it does the opposite of what it seems when it's inside on the function here? Well, even when we put it in front of the parenthesis, plus or minus in here, this still does an inverse relationship. So it's 2 pi over b. And we will not do any with a negative b value. So the period by definition is the length of one cycle. You can measure the period anywhere. You could start here and measure to here. You could start here and measure to here. Okay, it's however long one cycle is. All right, so these are the two that you have to know today. Only those two. And I am skipping all the way to number 7. Find number 7, it's on the back. Number 7, find it? Okay. So we have y equals 2 cosine. Can anybody write this differently so that maybe it makes more sense to you? Pi over, or theta over 4 is really what? 1/4 theta, is that okay? Do you not have this question?
No, I don't.
What does yours say for the? This is question number 1? Okay, thank you. So it's question number 1. Now did you find it? I apologize. Okay, so the dividing by 4 is the same as 1/4. Did I lose anybody there? We're good on that part. All right, so we are talking about the a, the function, the b, and the x. We're only talking about a and b today. So here the a value is 2, which is going to change the what? Anytime you multiply out in front of something, it is a vertical stretch, right? So this is not called a vertical stretch anymore. It's called the amplitude, okay? It is a vertical stretch. It's stretching it up and down by a factor of 2. Anything inside of the function is the opposite of what it seems, remember? So 1/4 in here is actually not going to make it shorter. It's actually going to make it longer horizontally. The relationship here, b is 1/4, and the relationship we talked about was it's an inverse relationship. So how do I do 2 pi divided by 1/4? Yes, I flip the 1/4 over, so I get 8 pi. Everybody okay? So inside onto the function, inside of the cosine, not out in front of it, a 1/4 made it longer. It now takes 8 pi to complete a cycle. All right, so this is how I do these. I'm super lazy. And so can I just draw a cosine graph and then go back and put all the labels on there? Now, if I gave you nice graph paper that had everything labeled, it's a little bit trickier. And we don't have to draw it first. We could talk about what's the maximum going to be at every time. Okay. because the amplitude is 2, and the minimums are all going to occur at -2. So sometimes to help myself, I put some little, that's where I'm starting and stop. That's not very even, but we'll pretend. All right. B is going to be where it finishes out here, okay, or 2 pi over B. It's going to finish at 8 pi. I'm going to draw the shape, though, first. What is cosine? Did I start at the origin or the maximum? Okay, starts at the maximum. Now, these are almost like little quarter circles, okay? It should go down a quarter, then this way a quarter circle, then continue that. So you almost have a semicircle down there, and then a quarter circle here. They shouldn't be straight V's, okay? Mine's not very good, but. So, because of the 1/4 in there, this finished a cycle where we decided the period was 8 pi. Now, I'm going to go to a different slide for just a second here. I don't know why this doesn't come until later. Oh, did I skip it? I think I skipped one I wasn't supposed to skip. Here. Did we talk about this one? You find the period of the function and then you successively add the period divided by 4 to get what are called the quarter points, okay? Quarter points. And you have to graph and label 5 points in one period. That's quarter points plus both endpoints, okay? And you can't use decimal approximations. So on this one, okay, halfway here would be what? 4 pi, and half of that would be, so where's the 2 pi go? Okay, but it should be right where it crosses, right? Because it's halfway is the minimum, where it crossed should be the quarter points. So if we took the period of 8 pi, you're always going to divide it by 4. And that's going to tell you how often your quarter points are. Now, if you have a phase shift, you have to add those on and it gets messy. But this one, because it started at 0, you just go 2 pi, 4 pi, what? 6 pi. Okay. Now, you need to write ordered pairs. So this first ordered pair was what? 0, 2. This one is 2 pi 0. So I'm just going to put, hello. How do I lose my cursor randomly? 2 pi 0. I'm not going to try and write it twice. There we go. Down here at the minimum then is what? 4 pi. And if it was 2 up, it's 2 down. So this is -2. And the ordered pair at 6 pi is 0. And the ordered pair at the end is 8 pi 2. Everybody okay? All right. All right, we have 2 more to do. How much time do we have? Is it like 12 after? So we got like 5 minutes? We're good. All right. What do we need to know about this one? What's the 3 tell us? Amplitude is 3. So the maxes, because there's no vertical shift, the maxes and mins are going to occur where? Yes. All right. This 2 is the B value, but it's not the period. 2 pi divided by 2 would be the period, which will be pi. Now, is that making it longer or shorter? Across. It's making it shorter, right? It has to finish the whole cycle by pi. I don't care what scale you use. So if yours doesn't look shorter, that's okay with me. I don't care. It's just got to be labeled. It's actually a smaller period. All right, where are we going to start, though, for a sine graph? Yes, it starts at the origin, not at the maximum. All right, so again, it's a quarter, but it's a stretch quarter circle. and then a quarter circle down. Doesn't look like a quarter circle anymore because it's stretched, and mine isn't very symmetric, but it should be, this is halfway to here. Doesn't look very good. All right, so where did it finish by? Okay, now we got to divide that by 4 to find quarter points. So we have a pi over 4. That's going to be the maximum. Add another pi over 4 to pi over 4, and you get what? Add another pi over 4. All right, so the ordered pairs real fast. Anybody got them? 0, 0. Pi over 4, 3. Pi over 2, 0. I'm just going to write that one there. All right, so those of you who haven't seen this stuff in a year and a half, is it coming back to you? Or 9 months or however long? All right, one more. This one's got something funky going on. Number 9. Oh, this is your number 3? Yeah. Thanks. Okay, 2 funkiness going on. This is a reflection, and this is not something we're real happy with, right? Because the normal period is 2 pi, and we got to divide it by 3. But this means it's flipped upside down. All right, I'm going kind of fast here. What's the amplitude? The amplitude is 1/2, so it's going from 1/2 to -1/2. The upside down part means the cosine normally starts where? Normally starting at the maximum. It's actually going to start at the minimum because of that reflection. So then it's going to go quarter, circle, quarter, rest of the way down. Okay, where did we say it had to finish? This period is 2 pi over 3. So this right here is 2 pi over 3. So this ordered pair is 2 pi over 3, -1/2. And it started at 0, -1/2. Okay, now to find the quarter points, we have to take 1/4 of this period, which is 2 pi over 3 times 4 over 1, which would be what? No, you're not dividing it by 1/4. You're dividing it by 4 or multiplying by 1/4. Sorry, I got in such a hurry that quarter point means divide by 4 or take 1/4. So it's 2 pi over 12, which would be pi over 6. So this is 1/6. What's 2/6, guys? Yeah, so the maximum here is 2/6 or pi over 3. And then the next one is 3/6, which is what? Okay. I'm going to finish label these. It'll be on the notes if you need it. But your homework, guys, is 2 problems. 2. Worksheet 11, number 2 and 3. It's the only 2 I want you to do this weekend. Other than that purple sheet, see if you have any questions. Because only part of the period Monday will be time to review for the quiz. The rest of the time, we're going to finish this lesson. Your class should be yes. What did you not get done? Okay, good. We'll see. It's going to get harder when we start